Hello all, today we are going to see about a clustering technique which is an unsupervised machine learning algorithm called density based spatial clustering of application with noise which is in short called DBSCAN algorithm. So these algorithms comes under the category of density based clustering algorithm. These algorithms generally make an assumption that clusters are nothing but the dense regions in space which are separated by the low density regions. So that means these clusters are nothing but the data points which are present in a dense region. So the more number of data points are located in a region, they are nothing but they form the clusters. So that's the idea behind these algorithm. So a dense cluster is nothing but a region which is containing. So this is again rephrasing the sentence. So the cluster is a region which is density connected. That is, the density of the data points in that region is going to be higher than the minimum requirement. So that is how we are going to identify the cluster using this algorithm. Okay, so these algorithm, what they do is that they locate a data point and they find the density connected data points in that region, and recursively they do this by expanding the cluster based on the dense connectivity. That's how these algorithms are going to work. So when these are going to work this way, so they can find clusters of arbitrary shapes. That's what they find. So this is an example of arbitrary shaped clusters. This is a density connected points. This forms one cluster and this forms another cluster and this forms the another cluster. So DBSCAN algorithm is one such example of density based clustering algorithm about which we are going to look at today. So this is about the, let's look into the DBSCAN algorithm. So as we said earlier, we are going to recursively find the dense areas and we are going to find the cluster and which are arbitrary shaped. So before going into the algorithm, we need to understand the two main parameters of DBSCAN, which are nothing but the epsilon and the min points. This epsilon defines the radius of the neighborhood region. So let's take a point P. So usually the algorithm starts by drawing a circle of radius epsilon and finding the points present in that region. So that radius is nothing but this epsilon. And this min point is nothing but defines a minimum number of points that should be contained within that neighborhood. So that circle is called as a neighborhood, and the min point indicates the density that is required by the algorithm. So these two parameters are the variables and it is fixed by the user depending upon the data requirement and the application's demand. Since we said the name of the algorithm is density-based spatial clustering of application with noise, it can handle a noisy data set very well, and we are going to see how this can be done shortly in this video. We also need to understand a few other terminologies like epsilon neighborhood. So epsilon neighborhood, that is n epsilon, which is nothing but the set of all points within a distance epsilon. So let's take a point P and a circle is drawn with a radius of epsilon. That means this is the epsilon neighborhood, and these points fall into this epsilon neighborhood. And we also need to understand what a core point means. A point that has at least min point, including itself, points within its epsilon neighborhood. That is a core point. So that is nothing. Let's take this figure. So let's say this point P is a core point. Let's assume that to call this point P as a core point, so we need to fix the min point. Let's fix the min point to be 4. That means the criteria it needs to get satisfied to call it as a core point. So if min point is 4, then including P, it has 4 points within this epsilon neighborhood, then this P can be called as a core point. That's what a core point means. After having located the core point, we now need to find the linked points. So there are two types of data points that can be identified that are linked to the core point. One is direct density reachable point, that is DDR point. A point Q is directly density reachable from a point P if P is a core point and Q belongs to the epsilon neighborhood. So let's understand using this figure. So now Q is present in this epsilon neighborhood and P is a core point, then this Q is directly density reachable by P. So that's what it means. So now the crux of the algorithm is that all these 4 points will be pulled into the cluster belonging to the P, and the neighborhood of Q will also be pulled into the same cluster. So that's what we are going to look into. So that is one direct density, factor that is direct density reachable. The other points are density reachable points. 2 points are density reachable if there is a chain of DDR points that link these 2 points. Again, we'll understand this using this figure. Let's assume that Q is also a core point. When we draw a circle with an epsilon radius and we find min points in this region, we can call this Q as core point. And now this R will lie in the epsilon neighborhood of Q, and R is direct density reachable by Q, and Q is direct density reachable by P. So now R is directly reachable by P. That's what this directly reachable density reachable by P means. So Q is directly density reachable by P, and R is directly density reachable by Q. So R is density reachable by P. So all the neighborhoods of Q and R will be pulled into the cluster of P. That's what we are going to do. Okay, so now after having pulled into the pulling the data points of the neighborhoods of the core points and their direct density reachable points and the density reachable points in the same cluster, we can also pull the other category of point into this cluster, so which is called as a border point. A border point is nothing but a data point which when drawn epsilon neighborhood will have a core point in it, but it will not have min point, will not satisfy the min point criteria. So we said min point is 4. Let's say the border point including itself is having 3, and including itself and a core point is having only 3 points in the epsilon neighborhood, in its epsilon neighborhood. Then it can't be called as a core point, but it can be called as a border point. But still the direct density reachable points and density reachable points of border points can be pulled into the clusters of the core points. There is one more category called the noise, so which does not come into the category of either core point or the border point, so which will not have any other points except itself. So it is an outlier. So this is how this algorithm is handling the noise data. So this will not be pulled into the cluster formed by the core points and the border points. This is eliminated, and that's how it is handling the noisy data. Yeah, this is how this DBSCAN algorithm works. So given a point, data points with us, so we arbitrarily pick a data point and we classify it as a core point, and we find the, and we proceed, we have to proceed the algorithm till we visit all the points. That's the aim. And we have to fix the min point and the epsilon, and we have to recursively expand this cluster by finding the core points and its directly reachable points, and direct density reachable points and density reachable points pulling to the cluster. That means what we are doing is that we are finding the density located, the points that are density located in the densely located in that region. So that's what we are going to do. So that's how we started this lecture as well. So the points that are located in a dense region are going to be pulled into the same cluster. That's what we are doing here also. We are finding a point and we are classifying it as a core point or a border point, and we are finding the neighborhood, and we are recursively doing it for all the data points and pulling the neighborhood point to the cluster. So the algorithm can be visualized using this. Yeah, so this is the border point. Let's assume that these are all core points. The points which are lying in this area is core points. So, and these are all going to fall into the same cluster. So we have located them as all the density connected and the density reachable and the density directly reachable points are all pulled in recursively and to a same cluster. And we can also pull the border data points and its neighborhood points into the cluster. But this noise will not be considered into the cluster and it will be eliminated. So this is how a cluster is formed recursively by arbitrarily picking a point and tracking its neighborhood. The complexity of the algorithm is going to be big O of n squared, where n is the number of data points we have with us. Obviously, the strength of the DBSCAN is going to be it can handle noise or the outliers very easily, and the weakness is going to be if the data point is having high dimensions, that means high features, then it will not be very easy to find the density between them. So that's where it fails. Otherwise, DBSCAN is good to find the arbitrary shaped clusters. This is about DBSCAN algorithm. Thank you.